Hi everyone, Nikunj here, co-founder at TrueFoundry, and today I'm going to share with you the exciting progress that we have made on the product front so far. Just as a reminder, TrueFoundry is solving the post-model pipeline for the user where they can go from experimentation to production within less than 15 minutes while following the best engineering practices like auto-scaling, versioning, and monitoring. We are building 4 specific parts of the MLOps pipeline, which is experiment tracking. That is a tool that people use to track all their experiments when they are training the model so that all these experiments are reproducible. Deployment, that is being able to push the model to production while getting an endpoint that can be integrated to the product. Model web app or a what if testing tool, which can be exposed to a business user who is a domain subject matter expert and maybe does not like to write code but wants to provide feedback on the model. And lastly, the inference monitoring and observability piece so that when things go wrong in production, it's easy to debug. Today, I'm going to cover the first 3 of these 4 parts. That is experiment tracking, model deployment, and model web app. And we will basically split this demo into 3 parts, where the first part we will just discuss the experiment tracking. In the second part, we'll talk about the model deployment. And in the third part, we'll talk about the model web app. So let's start with experiment tracking right from the code. So for experiment tracking, typically people bring their training script where they have loaded a data set, they have done some basic feature engineering. In this case, we are talking about a basic iris data set. So there is not much feature engineering required. People are able to train their model, compute their metrics, and so on and so forth. And now we want to make sure that all of this experiment along with hyperparameters and all the other details are logged so that it's easier for people to reproduce these experiments in the future. So this is the vanilla training script without any of the TrueFoundry code base. And now we start logging a few things. So I added 2 log lines here, one where I'm logging the training data set, the other where I'm logging the testing data set. Right now, because it's a small data set, I'm logging the full data set, but users can log just the statistics of the data as well. And after this, I am logging these 3 other log lines, which is logging the model, logging the parameters, and logging the metrics. And that's it. I add these few log lines, and then I simply run the training script, and this will start creating my experiments and runs directly on the dashboard. While this is running, let's go take a look at the dashboard of how the platform works. So generally, users start by getting an API key from our platform, which is the API key that I have pasted in the code here. And then all the experiments that they have logged, basically all the projects that they have logged, starts to get created, starts to get logged in this all projects tab. In this case, the name of the project that we have used is called Iris Recording, simply because I am recording a demo with the Iris dataset, and we should start seeing this particular project getting created. So we see that the project is already created. And when we go inside the project, we can see that there is a run called SVM model, which is the same as the run name that I have provided here. And this is currently in the running status. Not all the details have been logged so far. So when we get inside the run details, we will see that the details are empty here. But as and when the log lines specifically are getting executed, we will see more and more details getting populated in the dashboard. So we'll just wait for this run to complete. Meanwhile, I'll give a quick overview of this run details tab. So on the top, you are seeing a lot of metadata associated with the run. And here we have an overview of the run along with any metrics, data logging, system metrics, which is your CPU, GPU consumption, and any artifacts like code, model files, dataset that you might have logged. You're able to view all of that in one place. In the comparison view, so for the runs, when you have multiple runs here, you can actually go ahead and compare these runs as well, and these runs would start to get compared in these graphs here. We can go back and check that now our program has finished running. So all the metrics parameters are finished logging. We go back to the run details, and here when we refresh this page, we can see that our metrics are logged, all the hyperparameters are logged here. We see that we have our accuracy scores, F1 scores logged. For the data set, we log the train and test data set, and we can see the distributions of these dataset, compare them that our training and testing data are not widely different. Besides this, and by the way, point to notice here is that we never logged all these metrics and the summary of the dataset, but these are the details that have been automatically computed by the system. We are also capturing the CPU, GPU, disk percentage, etc., all the system metrics while the run is running. And again, this is something that is automatically captured by the system without the user needing to make explicit logs. And lastly, we have the artifacts where the user can go and browse all the artifacts like the dataset that they have logged, the models that they have logged. They can always download any part of the dataset that they have logged or we have computed in the backend. For example, we computed a lot of statistics. So the users can basically view these statistics, download the statistics so they can play around in their local system as well. This is the first part of the demo. In the next part, I'm going to show how are we going to deploy this model.